Evening. Today is Wednesday, January the 13th. Today in geometry, we looked at the converses of the theorems we looked at yesterday. Remember, we talked about a parallelogram and the properties of the parallelogram. So today what we're looking at is the reverse of that, which is if I have a quadrilateral, what do I need to show to prove that it's a parallelogram? So I will share my screen here and we will look at some examples. Now, if we have a quadrilateral here, so quadrilateral is just four equal sides, or four sides, doesn't have to be equal or anything. Okay, I'll draw it kind of like a parallelogram here because we're going to look at a couple of things now. So the thing we look at, we have basically four situations here, right? So given a quadrilateral, so we have a quadrilateral. The first situation says if both pair of opposite sides are congruent, then you have a parallelogram. Okay. Now, the second thing says if both pair of opposite sides are congruent, then you also have a parallelogram. The third thing says if the diagonals, I don't know how to spell here, if the diagonals bisect each other, then you also have a parallelogram. And the fourth thing, which is slightly different from what we saw yesterday, said if one pair of opposite sides is equal and parallel, then you have a parallelogram. So the type of problem we look at here, if I come to this situation here, if I can come in here and say, okay, if I have, let's say we look at this picture here, and this is 5, and this is 5, and this up here would be, say, 12, and this down here would be 12. Now, how do I know that that's a parallelogram? Because based on the second statement here, if both pair of opposite sides are congruent, which I have 12 and 12, and I have 5 and 5, then I know that I have a parallelogram. Okay, now I could also say if I come in here, let's say this angle looks to be about, let's say this is 100, and this is 100. And that would make this 80. And this 80. Now in this case, I have both pair of opposite angles congruent. So by the first expression here, I know that this would be a parallelogram. Now if I get rid of some of these, I'll get rid of these numbers that I put in here. Now, so the next thing we can do is we can come in here and say, okay, if I put my diagonals in through here. Then I can say, okay, if this is, say, let's say this looks like about 5. Whoops, I don't want to do that. Go back to here, do this. Okay, so this, if this is 5 and this is 5, and this would be, say, 4 and 4, then I can also say that this quadrilateral is a parallelogram because down here it says the diagonals bisect each other. And if these two parts of this diagonal are each the same, and these two parts here are each the same, then both of those diagonals are bisected. So that's the type of a problem you can look at. Now, if we look at, so let's go ahead and erase all of it. We'll erase this part out here. And we can erase this over here also. Now, so now if we come back in and we draw ourselves a quadrilateral, now the other type of problems I can get is I can have, let's say, this side over here is 2x plus 4. And this side over here is, say, 12. And then I could come in here and say this side is 3y minus 2. And this is 2y plus 2. Now, and the type of question you're asked here says, okay, what would x and y have to be in order for this to be a parallelogram? And of course, we go back to what we said. If the two pair of opposite sides are congruent, then it's a parallelogram. So to make it a parallelogram, I would set the opposite sides equal to each other. So I have 2x plus 4 equals 12. And I can solve this, and I get 2x equals 8. So I get x equals 4. And then I would go to the other one, and I have 3y minus 2 is equal to 2y plus 2. So I would also say that 3y minus 2y is y, and I do 2 plus 2, so y is also equal to 4. Okay, so the type of problems that you'll run into in your homework this time deal with these type of situations. And when you look at it, for instance, in this one, you know you're dealing with sides. So look back at the statement that deals with sides, which says that if both pair of opposite sides are congruent, then it's a parallelogram. If you have angles in here, then you look at the statement that deals with angles that says that if both pair of opposite angles are congruent, then it's a parallelogram. If you have diagonals drawn, then you know you're dealing with the diagonal bisection concept. And then finally, if you just have one pair of opposite sides here, if I were to say that this right here and this right here were parallel, then all I have to do to make this a parallelogram is to make these two equal, because it says if one pair of sides is both parallel and equal, then that makes the quadrilateral a parallelogram. Okay, so these are the type of problems that you'll be looking at. Now, tomorrow, I'll go ahead and stop the share here. Tomorrow, what we're going to look at, we're going to be looking at the same section, But in this case, there's a part of the section 6.3, if I'm not mistaken, that talks about the coordinate proofs and coordinate geometry. So you know we're going to be drawing pictures and we're going to be using the coordinates in distance formulas, slope formulas, and things of that nature to try to prove some of the properties of a figure. Or we can try to prove that a figure, for instance, is a quadrilateral. And we can tell it's a quadrilateral. We try to prove it's a parallelogram. And simply, if we have coordinates, we will sit there and take the slopes of the opposite sides and show that the slopes are the same. So that's what we're looking for tomorrow. And of course, Friday, if you look ahead, we will be doing the mid-chapter quiz for chapter 6. So once again, I hope you're feeling better, and I'll see you tomorrow.